Good morning, everyone. So this is our next lecture on binary tree traversals. I hope the previous topics are just fine because it's just a theory concept which you have to go through yourselves. So it is just the array representation part as well as the linked representation part. So you all know that we are dividing the trees into right link and left link. So L link and R link. So address of left subtree will be there in your left side of the node, and address of the right subtree will be there in your right side of the node. So likewise I have represented it periodically. Okay, so now let's go to the traversals part, that is binary tree traversals. So traversing is a method of visiting each node. So now when it comes for visiting, you don't have to worry much. Visiting is nothing but you just pass through that particular node. Okay, so it is exactly once in a systematic order. You just have to visit it. Okay, visiting is nothing but going through it. Okay, visiting it in exactly once in a systematic order. So during traversal we may print the info field of each visited node. Okay, so types of tree traversals, we have mainly three types of tree traversals, that is nothing but pre-order, post-order and in-order. So pre-order, post-order, in-order, three types of traversals we have. Let's go through one by one. Okay, so in pre-order traversals what happens is, so first you are going to process the root node. Process is nothing but visiting. Okay, visiting the root node. First you are going to check the root node, that is your first step. Okay, second step is nothing but traverse the left subtree in pre-order, that is left. So after first one you are directly coming to the left subtree, that is nothing but 2. Traverse the right subtree in pre-order. After the left you are going directly to the third one, that is the right part. Okay, so now in this diagram you can know that first you visit the node, that is nothing but the root node. Next you are coming for the left subtree. Next you are going to the right subtree. Okay, so these everything we are doing from bottom to top approach. So we are not coming from top to bottom, we are coming from bottom to top approach. So what happens here is, so let's take out the example. So this is the tree. Okay, as we all know, this A is the root node and this particular part is the left subtree and this particular part is the right subtree. So as I told you, we are going from bottom to top approach. Okay, so we are just representing the bottommost left side of the tree. Let's see what will happen. So if you take this as a tree, first is you have to visit the root node. Now you have to understand that D it is a left subtree for the root node A, but when you come to the individual trees, D is nothing but the root node for G and H, right? It is a parent node for G and H. So what happens here? When you are doing this tree, first thing is you are visiting the root node. So that is why I have written D first. Then after D, you will be going to G. So that is G. Next, you will be going to H. So D, G, H. So this whole thing becomes 1, D, G, H. First you have visited the root node, then you have come for the left subtree, then you have come to the right subtree. That is one part. Okay, so let's go to the right hand side. Right hand side, if you are taking into consideration, E is only having the right subtree, it is not having the left subtree. So what you are doing, first you are visiting the root node, so no left subtree, so forget that. So directly you are coming to the right subtree. So here it will be E and I. Okay, so now if you are taking this as step 1, so later it will be A is the root node which is having a left subtree as well as a right subtree. So if you are considering the left subtree, B is the root node. Okay, here we don't have right child, so forget that. So B, after B, D, G, H, right, as it is. So it is B, D, G, H. So first you are visiting the root node, then you are going for the left subtree. All right, that is what we have got here, B, D, G, H. So let's go for this one. So it will be C is the root node. Okay, C you are visiting it first. EI is the left subtree, so write as it is EI, and after EI you are visiting the F. Okay, so it is CEIF. So finally you will be remaining with the one whole tree. So here A will be the root node. So as you know, in the pre-order traversal, first you have to represent the root node, that is A. Next you are going through the left subtree, that is B, D, G, H. Then you are going for the right subtree, that is C, E, I, F. So function to traverse the tree in pre-order. So how do you write the function? That is nothing but, so void pre-order node root. So this root is the form of node. So if root is equal to null, you don't have any tree, then you just return. Otherwise, what you have to do is you have to first print, that is the visiting the node, right? Visiting the node is nothing but you are representing the root, you are printing the node. So printf %d root of info, that particular info you will be printing it. After that, you are going for the left side. So that is why pre-order root of L-link. So when I call the pre-order function, this itself will be called again, right? It is a recursive function. That means the same function will be called again. So what you will be doing? That particular root, you will be printing it and then calling the right link. So this will be keep on happening until you do this particular statements. So all of these will be printed by the help of this function. This is nothing but the pre-order traversal.